Let's try doing the evens of this factoring handout to get some more practice. Zoom in a little bit. Odds are done. Time for the evens, starting with number 2. Whenever factoring, first thing always, look for something common. Nothing. Now count the terms. 1, 2. The only thing it can be is difference of squares. Perfect square with a minus in the middle. Good to go. 2 sets of parentheses. In the front of each set of parentheses, you're going to put the square root of this. Share it evenly. In the back, the square root of this. Square root of the number and the square root of the variable shares it evenly. 1 plus, 1 minus, and the order doesn't matter. Done. Number 4. First thing we always are going to do is we're going to look for a GCF. And my GCF here is a 4. Factor that out. 4m squared minus 4mn plus n squared. So now I'm going to continue and I'm going to count my terms. 1, 2, 3. It's a trinomial. 3 different ways to tackle trinomials. I also have a coefficient, but it's also wacky because I have another variable here. But I look quickly and I notice my first and last terms are perfect squares. So I'm going to try the perfect square method. Take the square root of the first and the last terms, 2m and n. Multiply them together, 2mn, and double it. And if when you double it, you get this term up here, and we do, 2 times 2 is 4, mn, it's a perfect square. That is how we find our factor. Don't forget your 4 in front. I'm going to put the answer over here. 4, parentheses, 2m minus n. N squared. Okay, number 6. First thing we always look to do, factor out a GCF. So let's do it. So I'm going to pull out a GCF here, and no number, variable. Well, let's see. X's, I'm just going to look at the exponent. 4, 2, 2 means that I can pull out 2 x's. So here's an x squared. Y's, look at the variables and look at your exponent. 2, 3, 2. I can pull out 2 of them because they all have at least that many. So now let's factor it out. Well, I keep the 8 inside. 4, pull out 2, leaves me with 2. 2, pull out 2, gone. Minus 8, pull out 2, and y. So here is my y, plus, and pull that out, and pull that out, 1. And that's what I'm left with. Now sometimes I think, hey look, I still have an x squared, so I would try to factor again, but there's a random y here, and that variable is not squared. And unless all of your variables are squared, which means to an even power, to the second, to the fourth, to the sixth, then we can't do anything the trinomial way. So we move on. Number 8. First thing, always GCF. Let's find one. Okay, definitely not for a p, but maybe a number. 35, well that's 5 and 7. Yep, let's try 5. So if I pull out a 5, 7p to the third plus 5 out of 20, 5 out of 10, that's a 2p plus, and 5 goes into 60 12 times. So if you distribute, we would get back to our original. You can absolutely use a calculator and divide 5 from each of these coefficients. Count your terms, 1, 2, 3, 4. Okay, now we have to do grouping. So for grouping, we're going to group our first 2. 1, 2, plus sign here. So I'm going to jump right in and I'm going to group my last 2. I'm going to hold on to this 5 and kind of ignore it until the very end. Something common here, 7p squared. P plus, divide out a 7, 6p squared came out. Bring down your plus, pull out a 2. When you divide a 2 out, you get p plus 6. Hey, it's the same thing here and here. We have to have that as far as grouping goes, and when that happens, that becomes one of your terms, p plus 6. And over here, we're going to have our other term, that's all this outside front stuff, 7p squared plus 2. And don't forget your 5. And that is the answer for number 8. When we're finished with 8, we're going to move on to 10 on the next page. Okay, first thing we look for is something common. I do not see a GCF. 3 terms, no coefficient. This one shouldn't be too difficult at all. Let's jump right in. P in the front of each. Multiply to get a positive 54 and combine and get a positive. Well, when you multiply and get a positive, that means your signs are positive, positive, or negative, negative. In this case, they're both positive. So plus and plus. And we have to multiply to get 54. Okay, let's see if we can come up with all of those guys. Well, I get 1 and 54, 2 and 27, 3 and 18, 4 does not go in, 5 doesn't go in, 6 goes in. It's 6 times 9, 8 doesn't, neither does 7, and then we're back to 9. These are all of our choices. Remember, this plus sign here says that we have to add to get 15. Here we go. 6 times 9 is 54, and when you add those numbers, you get 15, 6, and 9. Okay, next one. Look for something common. 6, pull it out. P squared plus 4p minus 5. So now I always look to factor again. This square term tells you I can probably factor again. So let's 1, 2, 3 count the terms. No coefficient. So it's going to be one of those simple trinomial ones. P in the front of each. Multiplying to get a negative 5. Okay, I like 5 because my only choices are 1 and 5. So here or here. We'll figure out where those go. But we're multiplying to get a negative 5. So one's positive and one's negative. So let's see, because this is a positive 4, the positive goes with the bigger number, and the minus with the smaller number. Bring down your 6. Minus 1 plus 5 is plus 4. That's number 12 factored. Number 14, look for a GCF. And at a quick glance, I do not see one, so I'm going to have to factor this. It's a trinomial, coefficient in the front, and they're not squared numbers, so I'm going to have to start off my 2 sets of parentheses, and I'm going to put this in the front. It's a prime number, set it in stone, 5b times b. It's the only way to get that first term. 48, however, there are a variety of ways, so let's see. 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 doesn't go in, 6 times 8, 7 doesn't go in, and now we're back to 8, and we've already used it. So now we're going to be on this side. Okay, we have all of our pairs of numbers. Remember, when we multiply, or check these out, the outers and the inners have to subtract, there's your minus, subtract to give you 34. We'll figure out signs later. But we are going to guess and check these numbers and subtract to get a 34. Well, 1 and 48. I'm going to write these in lightly. You can almost make it out. Well, 5 times 48 is a gigantic number, and subtracting 1 does nothing to it. Okay, so let's put a 48 on this side and a 1 on this side. Well, 5 minus 48 is still in the 40s. I don't even have to figure out what it is, but I know it's still in the 40s, so that's not it. 24 and 2. 2 and 24. Well, 5 times 24, that's over 100. Minus 2 does nothing for me. Okay, so if I put a 24 here and the 2 here, well, that's 10 and that's 24. If you subtract, you get 14. Forget that. Okay, let's try the next one. 3 and 16. 3. Well, 16 times 5, whatever it is, it's way too big. So if we subtract 3, still does nothing for us. So what if I put the 16 here and the 3 here? Well, that's 15 and 16. If I subtract 15 and 16, I get 1. So forget that one. 4 and 12. Well, 5 times 12 is 60. Minus 4, way too big. Let's put the 12 here and the 4 here. 20 minus 12, 8. There goes that. Let's try this one here. If I put a 6 here and an 8 here, that's going to be 40 minus 6. Oh, let's see. I'm going to write it darker because I think this is it. 40 and 6b. But remember, when we subtract them, yes, we're getting 34. It's a negative 34. The negative goes with the larger number. Whatever sign that is always goes with the larger number, and there's my plus. So when I multiply to get 40, that's where the negative goes. Multiply in here to get the 6, that's where the plus goes, and this is your factored solution. I always start at the top. It's my habit. If you start at the bottom, hey, maybe you got that the first time around. Good for you. Number 16. Look for something common. I'm going to pull out a 6. 2x squared plus 5x minus 7. Ooh. Trinomial. There is a coefficient, and it's not a perfect square, but what I am noticing here is that this one and this one both prime numbers, so it should not be too difficult. I'm going to set the front in stone, 2x and x. I'm also going to bring down my 6 so I don't forget it, and I have to multiply to get 7. These numbers are 1 and 7 or 7 and 1, and whatever I do, I have to subtract to get 5. Well, 2 times 1 and 7 times x, whatever. So 2x times 1 is 2x. This here is 7x, and that's what I can subtract to get 5x. It's a positive, so positive goes with the larger number, minus with the smaller. When you multiply to get the 2x, that's where your minus goes. 7x, that's where the plus goes. Okay, hopefully that extra practice was helpful.